Hello everybody, in this video I will show you how to solve this probability problem. As you can see, the problem states that the actual tracking weight of a stereo cartridge that is set to track at 3 grams on a particular changer can be regarded as continuous random variable x with which is the most important part, probability density function given as this function here. So, the first question for us is to find the value of this k here. So, how do we do this? Since this is probability density function, that means with the limits of 2 and 4, that means that, for example, if we put it on a graph, and if we imagine that this is 2 and this is 4, and this is this function, for example, that means that the area under this curve here has to be equal to 1 if this is valid probability density function. And why it is like that? Because as we know, this is all the cases that are possible. And if we take all the cases that are possible, the probability has to be 1. And so that means if we put this function here as an integral, we will write it as this, like this. So it will be integral of limits will be 2 and 4, which are given. And now we will write the function. So it is k times 1 minus x minus 3 squared. That is our function. Since we said that this area has to be equal to 1, and we calculate the area with this integral, that means, so this is dx, that means that the solution of this integral has to be 1. And so now we will just solve this integral. So, the first step, we see that this is k here, and it is some constant, and it is not dependent of this x. So it means we can move it in front of the integral from 2 to 4. And here we will now have 1 minus x minus 3 squared dx. All this is still equal to 1. The next step we will do is we will get rid of this bracket here. And as we know, this is the same as it is written. So we know that a minus b squared is equal to a squared minus 2ab plus b squared. This is the property we will use to get rid of this bracket here. So now this will be equal to k times, from 2 to 4, 1 minus, and now we will have, so as we see here, it is a squared, our a is x, so it will be x squared, 2ab, so we know 2 times, b is 3, so 2 times 3 is 6, so it will be minus 6, times a, which is x. And the last part will be plus b squared, which is 3 squared, which means 9. Again, dx. And also, everything is still equal to 1. Now, we will write k times again, 2 to 4. And now we will get rid of this bracket, since we don't have no square, no cube, nor anything. So it will be 1 minus x squared. So since here we have minus, these signs will change. So this was positive, now it is negative. This will be plus 6x minus 9. And again, dx. And still it is equal to 1. So now, as we have here, it will be k times integral of 2 to 4. And now, here we have 1 minus 9, which is minus 8. Minus 8 minus x squared plus 6x. Still times dx. So this is our integral now, and still it is equal to 1. So now we will integrate this part here with respect to x, of course. So now it will be k times, and now minus 8, with respect to x in this integral will be minus, so it will be minus 8x. Minus x squared with respect to x will be minus x cubed over 3. And plus 6x will be plus 6 times x squared over 2. And now everything will be, of course, in the limits of 2 and 4. And everything is still equal to 1. If you don't know this part, then you have to learn how to do this simple integration, and you can find many videos on YouTube how to do that. And now, here, if you look at this part, we see that 6 and 2 will cancel, and now it will be here 3. So now we will have k times minus 8x minus x cubed over 3 plus 3x squared in the limits of 2 and 4, which is equal to 1. And now we will take our calculator and we will just simply solve this part here within these limits. So the first part will actually be, it will be k times, of course, and now the first part will be minus 8 times, instead of x, firstly we will write 4. So it will be minus 8 times 4 minus, so again instead of x we write 4, so it will be 4 cubed divided by 3, and then plus 3 times x squared. Again instead of x we write 4, so it will be 3 times 4 squared. And so solution of this part is minus 5.3333. And now minus, since this is the upper limit, so we calculate for that one, minus for the down for this lower limit. So it will be here. And now instead of x, we will write 2. So again, minus 8 times, now it is 2, minus x cubed, which is 2 cubed actually, divided by 3, and then plus 3 times 2 squared. And it is minus 6.66666. And still this is all equal to 1. Notice that we don't have limits anymore since we have solved it. So it will be k times, and now we'll just calculate this part. So it will be this part will be yeah 5.3333. So it will be k times 1.3333, and still this is equal to 1. And from here we clearly see that k equals to 1 over 1.3333, which is k equals 1 over 1.3333 is equal to 0.75. And that is the solution for our question. Now we have found the value of k. The thing you should notice here is that we have actually solved this integral here. And now I will remove all of these parts that are unnecessary. But we will keep the solution of this integral since we will be using it in the rest of this video while solving other problems. So this part is unnecessary, and everything here as well. But this part here, which is circled already, is indeed really useful. So we know that this equals to this. So we will use, instead of every time when we are calculating the probability, instead of calculating this integral all over again, we will just use this part here. That's why I will rewrite it down here. The next question we will solve is this one. What is the probability that the actual tracking weight is greater than the prescribed weight? So the first thing we notice in this question is the prescribed weight. What is prescribed weight? Well, that is this weight here, which is written, which is 3 grams. So now our question said, what is the probability that the actual weight will be greater than this prescribed weight? So it means that we are actually looking for the probability that our x, which is the actual tracking weight, will be greater than the prescribed weight, which is 3, as we know here from here. So now we are looking actually for this probability. How we will calculate that? Remember the graph we wrote. So our limits are 2 and 4. Remember this one. As we said, the probability of all this is 1. That's why actually how we have solved how we have found the value of k. And now we are looking for the probability that x is greater than 3. So let's say 3 is here. So now we are looking for only this part here. So for only this probability here under the curve. Not all of it, but only this. So if you notice, our limits in the first case were 2 and 4. So from here to here. And now our limits will be 3 and 4. So it will be from 3 to 4. So now we will just write the integral. So our probability, this one from here, will be equal to from 3 to 4, and it will be the same. So it will be k times, which we know that is 0.75, which we have found, k times 1 minus x minus 3 squared dx. Now we have to solve this. As I said, we will not solve this integral all over again. That's why I have written this one here, which is the solution for that one. So we'll just rewrite it. So k, which is 0.75 times minus 8x minus x cubed over 3 plus 3x squared. And now what will change actually is the limit. So we know at the first case the limits were 2 and 4, and now our limits are 3 and 4. And now we will just calculate this part for these limits. So now we'll take a calculator. So 0.75 will remain times, and now the first thing for 4, which is minus 8 times 4 minus 4 cubed divided by 3 plus 3 times 4 squared, which is equal to minus 5.3333 minus, and now for the 3, the same thing, which will be minus 8 times 3 minus 3 cubed divided by 3 plus 3 times 3 squared, which is exactly minus 6. And now when we calculate this, it will be 0.75 times, and now this part will be minus 5.3333. This part will be 0.6667 times 0.75. 0.25 is equal to 0.5, which is the actual probability, and this is the answer for this question. So the probability that this actual tracking weight will be greater than the prescribed weight, which is 3 grams, is exactly 0.5 or 50%. Our next question says, what is the probability that the actual tracking weight is within 0.25 of the prescribed weight? So, as we know, our prescribed weight is 3. If we say that something is within 0.25, it means that it will be in the range of, so 3 minus 0.25 is 2.75, and the other side is actually 3.25, which is 3 plus 0.25. So our question is actually, what is the probability that x will be between 2.75 and 3.25? So now, all the solution is actually the same. Just we will change these limits. So if you remember our graph, we have 2 and 4. Everything is 1, as you remember. And now we are looking for 2.75, let's say here, and 3.25, let's say here. So now we are just looking for this area here. And how we will calculate it? Well, we'll just put it in the limits in the integral. So we have our integral, and now our limits are 2.75 and 3.25, which is k times 1 minus x minus 3 squared dx. And now we will solve it. As I said, we won't solve this integral again because we have solved it once, so we will just rewrite the solution. So it will be k, which we know is 0.75 times, it will be minus 8x minus x cubed divided by 3 plus 3x squared. And now the only thing that changes is actually the limit. So now we go from 2.75 to 3.25. And now, again, we will take our calculator and we will calculate this part here. So 0.25 will remain. It will be. So now we will calculate this part here for 3.25. So it will be minus 8 times 3.25 minus 3.25 cubed divided by 3 plus 3 times 3.25 squared. It is minus 5.75. Minus, and now the same thing just for the 2.75. So it will be minus 8 times 2.75 minus 2.75 cubed divided by 3 plus 3 times 2.75 squared. And the solution is minus 6.24. And now this will be equal to 0.75 times minus 5.75. So this part here is 0.494, and this will be equal to 0.371, which is the actual probability that the actual tracking weight will be between 2.75 and 3.25. This is the answer for our question. And our last question for this problem is, what is the probability that the actual tracking weight differs from the prescribed weight by more than 0.5 grams? Now, how will we calculate this? We know that our prescribed weight is 3. So, what is the probability that our actual weight will differ by more than 0.5 grams? So it means that our actual weight will not be, between 2.5 and 3.5. So it has to be on this side or on this side. If we draw our graph, it will be like this. So let's say 2.5 is here and 3.5 is here. So we know this is 1. And now we are looking for this part here. So what is the probability that it will differ more than 0.5 grams? So we are looking for this part here. And how will we calculate it? Well, we know that this part here inside, which we are not looking for, is equal to probability of that x is between 2.5 and 3.5. And we know that the area of all this is 1. So this area here and here will be equal to 1 minus this probability here, which is the probability of 2.5 less than x less than 3.5. So now we will just calculate this part. So we will firstly calculate this one, which will be, so we will write it as an integral from 2.5 to 3.5. And now to the k times, we have it written here, it's 1 minus x minus 3 squared dx. And that's it. And now we know that the solution of this integral, and you can check it, is 0.75, which is our k, we calculated it before, times minus 8x minus x cubed divided by 3 plus 3x squared. And now the limits are 2.5 and 3.5. So we will calculate this part. So this will be 0.75 times, and again our calculator. So it will be minus 8 times 3.5 minus 3.5 cubed divided by 3 plus 3 times 3.5 squared, which will be minus 5.5416 minus, and here the second part, second limit, is minus 8 times 2.5 minus 2.5 cubed divided by 3 plus 3 times 2.5 squared. And this is minus 6.4583. And then, when we calculate this part, it will be 0.75 times. So this part will be 5.5416. It will be 0.9167 and this is times 0.75, which is 0.6875. But remember, this is only the probability, this one. But the solution for our question will be 1 minus this probability. So it will be 1 minus this value here. So our solution is equal to 1 minus this, which is 0.31245. And that is our solution for this problem.